Assalamualaikum and hi everyone. Today we are from group 5. We presenting the group project task about water distribution. The content had been present is introduction, methodology, result indication and conclusion. My name is Muhamad Al-Hakim Zailan. For introduction, the analysis of fluid flow through the use of a hydraulic network with very few or many interconnected branches is categorized as pipe network analysis. The objective was to find out what the flow rates and pressure drop are in each segment of the network. To solve the issue, water utilities mostly use specialized software. However, may be solved with less sophisticated tools such as spreadsheet, solver or contemporary graphic calculator. But now, we can use pipe friction laws such as Darcy-Weisbach equation. In general, head laws are each not are ignored, and a steady state flow solution is found for the network, taking into consideration pipe length and diameter, pipe friction characteristic, and now flow rate or head losses. Our group will conduct multiple loop for the pipe network system in this project. The outlet and inlet value are indeed given, including Q in at M is 0.1 and Q out at B 0.02, K is 0.03 and I is 0.04. And all you need for Q is meter cube per second. So that's all for introduction, and next we move to the methodology.
Hi, my name is Muhamad Jabri Aqil bin Johari. Now I will continue with the methodology part. In this group project task, we are required to find the discharge value for the water supply system in town A by using the Hardy-Cross method with Darcy-Weisbach equation as shown in the slide. The Hardy-Cross method is an iterative method for calculating the flow in the pipe system when they have provided the input and output flow. Next, a little bit of history. The Hardy-Cross technique is actually a modification of Hardy-Cross moment distribution, which was developed to determine the force in statically indeterminate structure. Lastly, not to forget, the tabulated friction factor for the pipe network in the pipeline, the inlet, which is the value of M, the outlet value of K, B, and I of discharge point are provided for this task. So we just need to find the discharge for the loop at 3, 4, 5, and 6. And to find that, we are using the discharge formula below for unshed and shed pipe. That's it from me. Thank you.
Hi, Assalamualaikum warahmatullahi wabarakatuh. My name is Amirul and I'm going to explain our next presentation, which is results and discussion for this project. So this is our water supply system. Consists of 4 loops, which is loop 3, loop 4, loop 5, and loop 6. It was also given the value of Q inlet, which is 0.13 meter cube per second in pipe M, and also Q outlet in pipe K, pipe B, and also pipe I. So in this study, there are 2 types of pipes that we need to consider, which are unshed pipe and also shed pipe. So both types have different methods in calculating the discharge value. So based on the pipe system, the shed pipes involve a pipe FH, HI, HL, and also GH. Okay, so in this study, we need to determine the discharge value using Hardy-Cross method with Darcy-Weisbach equation. So the friction value was given and the value of length and diameter also given, but we need to change it in meter. So the K value can be determined by substituting the value into the formula. So for the first trial, by looking at the picture, we need to assume the discharge value and its direction for each pipe. And the total flow in must equal to total flow out. So in this study, we consider that clockwise flow to be in positive and counterclockwise flow will be in negative direction. Okay, let's begin with the trial number 1. So we can construct 4 tables representing all the loops. So we have loop 3, loop 4, loop 5, and loop 6. So we just need to put all the values that we obtained before. So the Q number 1, we then consider the shed and unshed pipes. Then we calculate the HF value and also the HF of the Q value to find out the correction value using the formula shown in the picture. So the results of the correlation must reach 0.000 as value. So none of them meet the criteria. So we need to proceed with the trial number 2. So we shall continue with trial number 2. Same usual as trial number 1. So we need to construct a table and put all the value except for the value Q. So for trial number 2, we need to consider about the unshed and shed pipes for determining the Q adjusted. using the formula mentioned below, and then we need to calculate all the methods same as goes to try number 1 to find the correlation value. So from the results, none of them reach the criteria, which is 0.000x value for these two loops. Hence, we need to continue with try number 3 that will be presenting with my members. So I think that's all from me. Thank you.
Hi, my name is Ridzuan, and I will continue to explain about our trial 3. For trial 3, we need to consider about the unshare and share part to determine the Q adjusted. And then we need to calculate the HF and HF over Q. After that, we need to find the correlation value using formula that were given. So the result value of correlation for trial 3 does reach 0.000, but for only one loop. So the calculation proceed with trial 4. And for trial 4, we need to consider we also need to consider about the unshare and share part to determine the Q adjusted. Same step as trial 3, calculate the HF and find the HF over Q, and then find the correlation value using the formula given. And for trial 4, the result value of correlation has reached 0.000 for at least two loops, which are loop 5 and loop 6. So this is the last trial.
Assalamualaikum, my name is Muhamad Asyman and I will present the completion of this project. In any network of part 9, zero algebraic sum of pressure drops around the closed loop meeting at a junction together with any external flows must be achieved as there can be no discontinuity in pressure. The flow rates and pressure heads must fulfill the equations of continuity and energy. Well known as the head balance or closed loop method, Hardy-Cross method is applicable to closed loop sparse network, and since this method relies on only simple mathematics, process to solve a system of equation is considered easy. Without it, the engineers would to solve a complex system of equations that include with variable exponents. A decent distribution system should provide sufficient water pressure for the consumers in a specific flow rate, while the purity of distributed water should be always maintained, as the maintenance of the distribution system should be economical and easy. Not only has enough to meet consumer needs, the pressure also not to be excessive due to pressure leakage to save costs. In addition, during the malfunction of the particular pipeline network and need to be repaired, water for consumers should remain available from other pipeline and can be distributed without any big problem. That's all from me. Thank you.